Hello everyone and welcome to my science project. And this is my science project, and thanks to Mr. Kim, thanks to you who are watching it, and also thanks to all my friends and people who supported me all the time. Thank you guys all. Thank you so much. Purpose and outcome. You have observed that when placed in water, some object floats and some others sink. You may also observe that objects seem lighter when you hold them underwater. The explanation for all these observations has to do with the type of force called buoyant force. The purpose of this activity is to learn about the ideas to account why these things floats or sink. This is the warm-up for this activity, and the question was, what keeps the boat afloat? And I would say it's a force that pushes the boat up on the water, which keeps it afloat. So what is buoyancy? It spells as B-U-O-Y-A-N-C-Y. It means the ability or a tendency to float in water or air or some other fluid. Buoyancy is a liquid or fluid that can have a force that pushes the objects up and make it lighter or float. I believe that the buoyancy force is a force that pushes the objects through gravity, which the buoyant has to push under the water, and it makes it floats on the water or sink or stays in the middle. We did an experiment that we supposed to fill the object on air and fills it with our hand and object in the water. Just by feeling the objects on the air, Just by feeling the objects on my hand, I know that the object will be lighter in the water. And I think this is because the gravity and the buoyancy were being balanced. So when I placed my hand in the water, so the objects were being held up by the buoyancy in the water, which actually makes the objects heavier because the gravity is dragging the objects going down. So then it balance each other, which makes the water hold up your hand and the objects. I haven't do the buoyancy experience for a long time, but as what I see in other people's video, it says they have done for 5 newtons, and when they put into the water it was 4 newtons. So the conclusion was the sprint cell went up because the objects were getting lighter. But I believe that the buoyant force for this statement is gonna be a differences of an object with and force and with and without gravity weight, which that actually means that without the gravity and the force that hangs on the objects, what is the weight when it's on the water? These pictures shows that the point I've just talked about during the last clip. So there are many ways to figure out the buoyancy. One of the common ways was use the number after the object placed in water in a few minutes, and minus. Then the weight of the object was in the air, and subtract the number. But in many times we don't use the tools to do that. Then we have to use display waters times 9.8 squared. And that was the method 2, which will still lead us to the buoyancy. but the displaced water in the water that went out from the container, the 9.8 squared is a calorie of the gravity. I remember when I asked people in the church that why gravity was 9.8, and a genius told me that a bunch of stuff that I don't know. I heard that you have to divide your weight by 9.8 and so you would get your mass. Even I think it's kind of useless. So back to the topic of the second method. I don't think it might be better than the first topic because the scale will shows the number of the weight exactly, but the second method should getting messed up by filling more or less water that you're supposed to. So I like to use the first method more than the second method because it shows you how exactly it works. So for example, the first method can be used as the last example, which is 5 Newton and 4 Newton. So all you have to do is subtract 5 and 4 and you got 1 Newton for your buoyancy, and that is your answer. But for things like the second method, you have to actually do the multiplication and other things, and actually your answer might be messed up. I don't have an exact number for the answer, but I can tell us what's gonna going on after this. But the buoyancy actually won't change easily in the two method work. So what is density? Density is mass divided by volume. Density is used to determine an object float, sink, or stays in the middle. So it says that the density is less than the object float. If it's more than, then sink. If it equals, then it will stay in the middle. That's why calculating density was important because it determines it will stay, or it will float, or it will sink. I know I skipped a lot of things, but in conclusion, the buoyancy, it is a force that pushes the objects to make it float, sink, or stays in the middle in the water. And there is the other force, that was weight force, that's using the gravity that pushes the objects through to the water and try to make it sink, which they start going against each other, and the weight was getting lighter, the object is start getting lighter, and that is why that when you put your hands in the water, and it will feels lighter than when you did it on the in the air. So then the density was a special unit that used to determine is the object float, sink, or stays in the middle. And there were two methods that can actually do to measure the buoyancy of an object. One is to find the differences between the weight in the air and in the water. The other one is to use the explored water and multiply by 9.8, which is the Aquari gravity. So then I conclude that all these things I learned about buoyancy, this is the buoyant force. That's what I believe.